Brilliant. So welcome everybody to this very first technical webinar of ASHVIN project. We will have 1 hour to discover what has been ASHVIN doing in terms of innovation in digital twin and smart building tools. And I just wanted to highlight that we are recording the session and that we are also doing a live tweeting that starts now for those who want to follow the session online. We have today 4 speakers, Timo Hartmann from the Technical University of Berlin, who is the project coordinator and professor at the university. Rahul Tomar, and he's the CEO of Digital Twin Technology and the technical coordinator of the project. Then we will discover what Manuel Jungmann, who is a researcher and task leader also at the Technical University of Berlin, and Rolando Chacon, who is an associate professor at the Technical University of Catalonia and also work package leader. So they will present their research in this work. And so I would like to warmly welcome you. I'm Mona Maril. I'm the communication leader in the ASHVIN project and the project manager at Australo Marketing Lab in Spain. So we have only 1 hour, so we should keep it going right now. So firstly, Timo will do his introductions and present you the overall goals of the ASHVIN technology and how it supports the construction industry today. Then Rahul will give you more details about our digital twin platform and how it works and how it serves the construction site managers. Then you will discover 2 use cases that are presented by Rolando and Manuel from 2 different demonstration sites that we roll in ASHVIN. There will be also some space for questions and answers. We really hope that this is an interactive session. So please keep your questions towards the end, and we will make sure that we respond to your queries. And also then we will share you more information to how we plan to open the platform for external stakeholders. This is something we will wrap up with Timo's finalizing words. So thank you, and I pass the floor right away to Timo.
All right, thanks, Mona. Hope you can hear me well, and sorry for my technical problems connecting. So I think I just have like a quick overview of what the project is about and what we are trying to achieve, or where we stand actually. And so prepared just a number of slides for you so you can get a basic overview. So basically, ASHVIN is one of the large Horizon 2020 still, but one of the large European research projects that work in consortia of partners across Europe. So we have 14 partners across Europe. Here on the right-hand side, you see a map where they are all located. And we work together in a 3-year research project that is now in the last year, and we received 5.6 million euros of funding. What is the basic objectives that we want to achieve? So we all know, hopefully, or I assume here in the meeting, the construction industry is one of the most important industries in Europe, but faces really significant challenges and problems. And one problem is productivity. I just have one key point. Of course, there are many different other problems that are caused by productivity, but construction projects on average take 20% longer than expected. And also, I think we need much more resources on these projects because of the productivity, which leads to resource efficiency. Right? So here just a couple of facts: 2 out of 3 construction projects exceed their budget by more than 10%. Other things in terms of sustainability, for example, is that the average idle time of construction equipment is 40%, up to 30% of the overall CO2 production of a construction project can be attributed to the construction phase. And so there's a lot of CO2 that is wasted during construction that we can optimize on. And then the rework on construction projects accounts for about 90% of the overall cost of the project. And then final problem that we are facing is safety. And I don't need to say much, but we have not acceptable safety statistics in the European construction industry. So what are we trying to do on ASHVIN? On ASHVIN, we really try to develop validated methods and procedures to make use of existing technologies that allow for better scheduling forecast. Our goal is 20%, allow for the better allocation of resources, reduce the number of accidents, and overall reduce the cost of construction. Our target is 20%. And we know that there are a couple of technologies available that we called, or we gave them different names. Like, we know that we can do simulation-based planning. We can do construction monitoring, right? With technologies and digitizing these practices. We can digitize the safety management on construction sites, also ensuring privacy of workers, which is an important thing. And the last thing I think that we can do when we need to digitize in the industry is configuration management. And so with applying all of these tools and applying these really on a large scale on construction projects, right, we believe that we can be really on time for work task, right? We can change scheduling, right? At the moment, we have a long lead time to schedule work. So oftentimes we schedule work 6 months ahead, 9 months ahead, 12 months ahead, right? But I think with better digitization, we can maybe schedule 1 week ahead, right? We can reduce the overall project delays, right, to initial project schedules as well. We can think of, reducing the non-productive work time here on sites. We can, of course, I already talked to that, a big problem. We can reduce the idle time of heavy construction equipment, and we can hopefully reduce the greenhouse gas emissions during construction work. Maybe we can also reduce design and engineering hours, reduce utilization of heavy equipment, reduce scrap materials and other waste, reduce rework, reduce preventive maintenance through predictive maintenance. And we strongly believe, and I think there's like cases all across the place that show that these possibilities are really there, right, by digitizing the construction site. Here are a couple of things that we believe we can use for safety. But what's the key to all of these digitizations? So one thing is we need to really start being able to progress or track construction progress on site. And these are like some complex flow charts that we developed in the project. You can read them up in the deliverables. I can't, in the 10 minutes I have discussed them in too much detail, but we can really start tracking construction work. We can, use data that we collect from tracking construction work to really estimate how long things take, to understand productivity better, to understand waste better, to even simulate future construction work options, scheduling options, right? And the second thing is that we can really do to improve all of these things and digitize is really configuration and quality management. So this is again some sort of figures that show how we envision a better quality management project on site, where you really use digital tools to really understand what has been put in place on a construction site, compared with what should have been in place, and then understand and make better decisions, right? Why we are here today is because we strongly believe that there are technology enablers which we can make available now through the ASHVIN project, and want to make available also in the project to further demonstrate and explore the possibilities. But it's all about, on the right-hand side, right, monitoring. So we do something in the real world, the construction site. The construction site should realize some design. And if we have better means to monitor what we do on the construction site, we can really reach all of these goals. And so what does monitoring mean? And so we talked then about the digital twin of the construction site, right? So we can monitor the construction site using digital means and then understand what's going on the construction site at any point in time, because we have a digital representation of what happens out on the site. And we also have the historical information of what happened in the last week, in the last 2 weeks, in the last months, right? What's the enabler? And we strongly believe that the technical enabler for this is the Internet of Things, because the Internet of Things allows us to integrate all type of tracking sensors, video cameras, and so forth seamlessly into this digital system, and allows us to really collect the data in real time without, needing to implement really complex computer science-based systems, right? So, and that's one of the things we were really working hard on the ASHVIN project, is to develop such a digital twin platform that is based on an Internet of Things that allows you to integrate sensors and cameras and other, data collecting devices that you might have on your construction site. And with this information, you can then hopefully reach all of these things I just presented. Here's just an overview about our ASHVIN toolkit. And that's a little bit of a short introduction. 10 minutes I had, I think I was in time. And I guess my colleagues from the ASHVIN project will now show you a couple of examples of how we used this IoT platform and the digital twin platform on construction projects already, to give you kind of like a taste and the feel of where this could go to.
Thanks a lot, Timo. So Rahul, now I would pass the floor to you, please. So Rahul is the technical coordinator of the project, and he will be presenting us more in details the IoT-driven digital twin platform we are working on. So please go ahead, Rahul.
Sure. Hello, everyone. So I'll present here. So you can see my screen now?
Yes, perfectly.
Okay, great. So as mentioned, in the ASHVIN project, all the consortium partners, we have developed 11 total digital tools. We are not going to present all the tools in today's webinar. It will be because it's a series of webinar, we will do it one by one. So today from my side, I will present the first thing about the IoT digital twin, because as just now mentioned by Timo, the part of the IoT is very important. First of all, we have to connect and collect all the information from the different sensors and different devices within the construction site. So in general, what is the IoT framework? So there are things are considered as a sensors or gateways or any other devices which are generating the data. So those are the things on the construction sites. We connect those things via different mean of protocols, can be Wi-Fi, can be GSM, which is 3G, LTE or 5G. It can be LoRaWAN, it can be Sigfox. So we connect via any of these means, all those devices and sensors. Then we start collecting those data from these devices. The collection of these can be done in a different manner. So, and then we saved it into the specific database. For in our case, we are saving it in the time series database. After having this thing in our database, then we start learning it. That, okay, what is this data? What is the information what we are receiving, so that we can able to provide a proper graphical representation and also any predictive information for the construction manager. And then we start doing things. So whether it has to be for the generation of a graph or providing any information for the construction manager to take care of during the construction site. This is again the same image which Timo mentioned. So this is our IoT framework. As we can see, we considered it in a very different, deep way. This has been developed completely by our partner Mainflux, who has the industrial IoT platform, and we use this industrial IoT platform into the construction, into this construction industry. This IoT platform has already been implemented into the manufacturing area and has been under this with very good standards. So that's the reason that we have considered also this platform to be taken into ASHVIN project, so that we do not have to develop anything from scratch. So this is a list of standards. So there are 3 slides of list of standards, but I will not go through each and every standard. Why I'm trying to show here that the first thing for any construction company about collection of the data and saving of the data is about whether we are following the standards or not. Do we consider the existing standards which is in different industry, or the security of this data which we are saving into platform? Yes, we do, and this is what I'm trying here to show: different ISO standards which we are taking care within the Mainflux platform and ASHVIN platform, and also considering more to integrate in from different industry. Okay, so the point here is about construction site monitoring, that why we need this thing for the construction site monitoring with the IoT platform. There are one major reasons comes with occupational health and safety hazards, compliance with insurance regulations, and high cost of mid to long-term monitoring. These are the 3 points which basically the business pain points for the construction companies to take care of. If the site does not have the IoT platform or IoT connectivity, these things definitely they are doing it, but in a major painful way. That's why IoT will help it. IoT tool will help them to do these 3 things in a more easy way for them, and they can concentrate on their construction work instead of being the IoT people. For the key engineering pain points in that scenario comes the monitoring points are spread all over the large areas. The working environments are constantly changing because of maybe season, maybe day and night also. Cables are vulnerable to physical damage. So that's the reason that if the cables are vulnerable, so we have to do Wi-Fi connection, for example, or wireless connection, I would say. The construction site is huge, so you cannot spread the cables all over the places. So collect the data automatically, and also you cannot move around if the construction site is huge. So automatically data should have to come to the main central database point. So why should we consider using wireless monitoring system? It increases the efficiency because now the person do not have to go and collect the data and spread the wires. It reduces the cost and speed up the return of investment for a company, and ensure workforce safety. Well, definitely it will. Compliance to global standards, because the IoT standards, IoT platform which we are using, it's already existing from the manufacturing. So compliance from those global standards in that scenario. I like to give you a small demo in this case now. So this is the IoT platform from the ASHVIN. So we logged in, and once you logged in here, so this is one of the sites where we have created the sensor. So there are 2 ways of connecting the IoT sensors to the ASHVIN platform. One way, okay, you have sensors, so you can directly, in a very raw manner, that you create the thing, whether this is a sensor or whether this is a gateway in that sense. So for creating, you create the name and provide the information, the ID, and these IDs are basically when you have the sensors. So these IDs come available with them. So you add these IDs. The moment you add these ID and key, immediately the system start receiving the data once the sensors start sending the information for that case. This is in a very raw form to connect, which is where the involvement of our team required, that we go to the construction site, we collect these ID for the sensors, and we connect on the platform. Other way of doing it, it's that construction companies are already having the sensors. Now, where those sensors are having REST API connectivity, or they are saving somewhere in the database or CSV file. So we just have to create the interface to collect the data from either from the database where they are saving, or different databases, because all the sensors are in different places, or CSV files, or if they have the REST API. So we take this REST API for the digital twin platform. I'll show here that this is the ASHVIN digital twin platform. So we go here and take the one. This is Query World Rotterdam from Rotterdam. Obviously, this is one of the demo site for us. So in the digital tool platform, this platform is based on the game engine. We convert this into the browser-based application so that we can import the IFC file. So we convert, first of all, any BIM file, whether it's made in the Revit format or any other format, into the IFC, and then IFC to Unity, and then import it into digital tool platform here. Here we have the list of sensors here. So what we do, the sensors the construction companies provide us, that okay, these are the sensors has been installed. The first part is those connect those sensors to the specific BIM element, because to provide the relevant information that okay, where the sensors are located. So if we select here, so as you can see, the so 4 lines has been colored. So these are the sensors has been installed here in this specific part of the query wall. We load the data, and then we can see the information. These informations are historical and current, real-time also. At the moment, it is not real-time, it is historical data. But if the current real-time information is coming, so it can connect those parts. So real-time sensors information we save into time series database so that it can be visualized very quickly. And then for learning, for the part of the learning, we transfer the data from the time series database to the document-based database, so that we can organize the data and for the specific learning purpose. So this tool is quite handy in that scenario, that okay, you can zoom in, zoom out for that, and select different sensors for there. It changes the part and gives the information for those specific sensors which has been installed in the wall here. So that's it from the IoT part. So this is the very specific IoT part that we would like to inform at the moment, that the first part thing of the ASHVIN tool is connect all the sensors and devices on this platform, start collecting this thing. Then we start going for learning part. My other colleagues, they are going to show, okay, once we receive the information of the IFC files and the construction sequences, and the census data, how to utilize those information to provide all other information. Thank you.
Great, thank you, Rahul. So now in the webinar, we come to the moment where we will present you 2 different use cases related to the vibration and sensor system used for crane and concrete. And these use cases will be presented by our 2 researchers. So Rolando from the Technical University of Catalonia, go ahead first, please. And then we will also discover the second use case by the Technical University of Berlin. So please, Rolando, go ahead. We cannot hear you. Maybe you're muted, Rolando. Still cannot hear you.
Yeah, sorry.
Perfect.
Sorry.
Thank you.
Okay. Can you see my screen?
Yes, thank you.
Okay, thank you very much. This, yeah. I will present one insight of the Smart Building Digital Toolkit related to the one of the demo sites we have been working on. I'm very happy to be here. Thank you. Thanks, Mona, for the presentation. So this insight is related to one demo site, which is located here in Barcelona. I will present 4 concise points today: demo site, the preparation of the information, the virtual models, then specific insight, which I call here acceleration, and then some next steps for the next weeks, months of the project. The demo site is an office building, construction of an office building here in Barcelona. Okay, you can see here the map of the city. We have one big neighborhood in which many sites are under construction right now. So the office building is located right there in this neighborhood. This office building is a reinforced concrete structure that was opened by collaborators. Access was given to ASHVIN project. So this access was given for a specific module of this reinforced concrete building, which I highlight in red on the right part. This is the access was given there. So and the access in the space is there, and in time is we had access to that reinforced concrete structure while the structure was erected, okay, including the structure, I mean columns, beams, and slabs. So that was the access we had by collaborators, owners, construction firms, architecture firms, and site managers. So this is the module in which we were acting during some months, 6 months precisely. It's a quite regular structure, rectangular with 9 stories. So their schedule was a 6-month plan in which sequentially columns were casted, slabs, then columns, then slabs, and gradually during each of the time of the casting, actions were repetitive, let's say, okay, for this module. So it was interesting to have this perspective at the beginning of this repetitiveness to plan what was going to be measured and be embedded into the digital twin platform. So we needed some creativity to find ways to embed information into the digital twin platform, to think about the specific conditions of this specific site, and also we needed to have an agreement with the stakeholders to be sure that it didn't that it fulfilled the conditions for this collaboration with the stakeholders. Okay, so it's not only about what is technically possible, but also what it was possible at that specific site. So we came up with several ideas for measuring the cranes, measuring the fresh concrete, measuring the slabs, post-tensioning of the slabs, formworks, and also machinery. Okay, so all those ideas came from the specific site. They are site dependent. Cranes with IMU sensors, fresh concrete with temperature sensors, slabs with LiDARs, laser scanners, post-tensioning with strain gauges, formworks with accelerometers, and machinery with IMU sensors as well. And for each case, there were possibilities to embed in different parts of the digital toolkit of the ASHVIN suite, let's say. Okay, so in the site there was a coexistence between measurements, the 3D geometries, simulations, and eventually the most important part is the performance analysis during construction. So that was the idea. That was the, let's say, the big picture. So for taking measurements from the site to the digital twin platform, several steps are required, many of them already explained by Rahul, but I will focus now on 2 of them. Okay, the preparation of data flows and the development of one specific pipeline, which is called this insight acceleration. Okay, then we are on the 3rd year of the project, integrating procedures and performance analysis in the ASHVIN platform. So here, this preparation of the data flows is due to the fact that we had information from the stakeholders at the beginning, information related to the potential schedule, information related to the BIM file with certain high level of detail of development, but these BIM files required adaptation to the new, let's say, from BIM to digital twin procedure. Okay, so the information needed to be in a way that is readable by the digital twin platform. Okay, and for that, the preparation of the data flows, we needed to present or develop. Let's say on the left part, you see what we had from the stakeholders, the BIM file, and on the right, what we needed to add to that file to generate this coexistence between all other simulations and measurements and so forth. I will now open, please. Can you see now a different screen?
Yes.
Yeah. So this is the way we adapted that BIM file to the digital twin platform, in which not only the IFC building elements, columns, slabs, and beams were, let's say, used. This is what we see here is each independent set, like columns, slabs, or beams, but also we needed to embed other things such as sensors, IFC sensors within this system. Okay, so that was required first of all. Go back now to the slides, and once it was prepared, we focus now on this inside of acceleration. So this acceleration during casting, here you can see a picture of the moment in which concrete is casted in one column. Then there is a vibration in this column at that specific moment. And we wanted to track this vibration for many different reasons. One of them is, okay, if there is a vibration, it means that there is a column being casted. That is already good information. But also about timing, about the vibration, this timing was also interesting for further analysis. So vibration, you see now a busy slide on the left upper part. There is an accelerometer in the formwork of that column, giving information about the acceleration during vibration. You see a plot with a red line defining this movement. So this needed to be treated data sent to mainframe platform, the IoT platform, the data, raw data. And so the analysis was about time, how long this vibration took. And also all the information processed went to the ASHVIN platform, and the idea is to present this information in a way this is meaningful for the construction managers. And now I show this result of the treatment, in which how information from the vibration was tracked during construction to see what's the difference between the vibration between columns that may be relevant for construction managers. Okay, energy-wise, quality of material-wise, it's good to track. Okay, this is a way of presenting the information. It doesn't mean that the information red or green in this specific video is good or bad. It's just showing that it's possible to track this specific insight acceleration in a meaningful way. Okay, so we have now next steps, integration of other of those pipelines into the platform, focusing on the decision-making progress to show to this how useful it can be for the process. Another busy slide here that I present as well, that was developed by our team here at UPC, Hector and Carlos. So here we have, for instance, the evolution of the concrete temperature during casting that is then embedded in another tool, which is MatchFem, part of the digital toolkit. And we are now in the process of putting this together for in a meaningful way for decision makers as well. So with that, I end my presentation related to this specific insight. Thank you.
Great, thanks a lot. So Manuel, I will pass the floor to you. So this is the last presentation of the session coming from Manuel, who focuses on another use case. And then we will have some time for questions and answers. Thank you.
Hey everyone, can you see my screen?
Perfectly well.
Great, thanks. So welcome to the presentation of the desk tool. I will give a short overview. The introduction. Well, the desk tool supports project managers during the decision-making process of ongoing construction works by real-time discrete event simulation. It is applicable for 3 different construction process patterns: the mounting of prefabricated columns, the management of location-based finishing works, and concrete works executed by a tower crane. In the simulation, supply chain, resource-dependent, and spatial aspects of the construction site can be considered. And by using stochastic simulations, a multitude of possible construction options can be compared. This means different resource allocations or delivery options can be tested in a virtual environment in consideration of uncertainties like changing activity durations or weather conditions and so forth. And in the simulation, productivity, resource efficiency, and safety-related KPIs are calculated automatically. So in general, it can be understood it's an input-output transformation. So we collect raw data during construction processes to forecast KPIs to manage ongoing construction processes. This is a general framework Timo already showed. I will briefly explain it. Well, during construction processes, we collect data on site by sensors, kinematic sensors, cameras, and so forth. These data are sent via internet to the ASHVIN platform, which Rahul already introduced. And then we use machine learning to gain meaningful information from the raw data. The meaningful information are activity durations. And these activity durations are used for stochastic probability modeling to determine probability density functions. And these PDFs can be used as input parameters for a discrete event simulation. We model for each of the 3 work process patterns a discrete event simulation model in R, and the database PDFs can be used as input parameters next to other input parameters. And then we simulate all the construction processes, and within the simulation, KPIs are calculated, and the resulting KPIs and the processes are visualized on the digital twin platform for easy understanding for facilitating communication among stakeholders. And then the project managers, construction workers can use this information for the decision-making process, decide for a construction option, and then the construction proceeds and new data can be collected. And this is a repetitive process until construction works are finished. As mentioned, the important part, the crucial part is the collection of raw data and then to gain meaningful information, the PDFs. This is an example. We collected, for example, kinematic data by mounting a sensor on the crane hook to track the crane movement. Additionally, we had some time-lapse images during the mounting of prefabricated columns. These data were analyzed by machine learning, and then we got data sets of activity duration. Here you see an example for the first week and the second week. And next, we use stochastic probability modeling to determine PDFs. And as you can see, by an enriched data set, the PDFs are changing, of course, because construction processes are dynamic, uncertain, and yeah. And these PDFs, these database PDFs, are used in the desk tool as a next step. So we have some input parameters. This is an example for the mounting of columns. The prefabricated columns are delivered by trucks to the construction site and mounted with the help of a mobile crane and construction worker. And therefore, a timely delivery is crucial for successful construction. So in the tool, we have several input parameters. You can see on the left side, like number of columns, resource allocations, activity durations, but also weather forecasts, delivery options, and so forth. And yes, this is an actual tool in R. So you enter some inputs like the number of columns, how many columns per delivery, and the tool simulates a lot of construction possibilities. And in the end, you have the outputs, the KPIs, the construction durations, the productivity per worker or for the crane, the utilization rate of the crane, total costs, this means personnel costs, and also a safety factor is calculated. And yeah, finally, these resulted simulations, these KPIs are visualized on the digital twin platform. Can you see the platform now in my browser?
Yes, Manuel.
Okay, great. So you can open the platform, choose a construction project. And then you choose a desk tool. Then you could choose the KPI button and you see a dashboard and see the results for different construction options. The results are visualized in a spider diagram and bar charts. You can choose different KPIs and see valuable insights for different options. For example, the option 3 is leading to a quite low construction duration. Option 1 and option 3 entailing a high productivity for the crane and the workers, and additionally low cost-wise, and so forth. And then you can choose the planning button, and then the process simulation is loaded onto the platform, and you can see the simulated processes are visualized on the platform. If you're clicking on some activity, you see the delivery time, when was the column delivered to construction site, when the start time for the activity, the end time, and so forth. Additionally, you can click on the model on the column, and you see the information from the BIM model, like the IFC type and everything, the size of the component, and so forth. Well, this is the current state, so it's not the final state yet. We are still working on the platform. In the future, it will be possible to compare different processes in split screen. And additionally, the dashboard will be extended to provide detailed information about past processes. This means information about resource allocations, about the performance so far, like productivity, how was the productivity, how was the resource efficiency, and so on. Yeah, so that's a short description of the desk tool and how we envision to enable data-driven construction management based on real-time data. Thanks for listening.
Thank you, Manuel. So as a reminder, so the ASHVIN toolkit comprises the digital twin platform and 10 related smart building tools that we also developed in the project, and the desk tool that Manuel presented is one of the 10 tools. And all the entire system or parts of it are deployed at 10 different demonstration sites in Europe. And so here you saw 2 of the 10 demonstration sites. So now I think we can open the floor for any questions these presentations might have brought into your mind. So please just raise your hand and if you have any questions before we wrap up the session. No? Okay. Well, if you are thinking some, I will give you some more time. Maybe we can just, Timo, explain a little bit the process we would like to have of onboarding maybe new external construction projects on the platform. If in this session we have any stakeholders that would be interested in actually benefiting of the ASHVIN digital twin platform, maybe we could inform a little bit better what are our plans during this final project year to open up the solution for another new construction sites. Timo, would you like to comment on that one?
Yeah, sure. So I don't know, there were no questions. Maybe there would be some comments, some thoughts, of course, would be also always very helpful to what you just saw. So we showed a couple of examples that we developed during the project. Now we have this platform, and in particular, we have the IT backend. And with what Rahul showed with the Mainflux platform in the backend, we actually have the possibility to fairly quickly and easily, connect to any kind or most type, not any kind, but most types of sensors. So we were hoping that we could, in the last year, really demonstrate the platform for a larger community, just making it open for any type of construction project that already have sensors on the construction site, that plan to install sensors on their construction site, that want to experiment with some real-time data collection on their construction sites. We have the framework we can support. So we also have still personal resources to support. The easiest is we can just, if you already have a sensor on your site, we can just, you can contact us. And we can help you. We can set up your own, IoT connection interface. It's online. We can help you connect your sensor to there, and you can use the IoT platform to, see the sensor data that comes in real time. Right. So that's maybe the first step and the lowest hanging fruit. Based on that, we do have, large-scale European project, we do have experts that can start helping you to do something with the data. I mean, we showed you some kind of very, let's call it super fancy examples, right, of what you can do. There's certainly a lot of easier things and quicker and lower hanging fruits as well that are available in that sense. We have data analysts in the project team. We have experienced construction people, construction managers in the team that then can, maybe if you're interested, work also with you, to make sense of the data, apply data analytics methods. Manu showed some, I guess, Rolando showed some. Start thinking about how you can tie into some simulation tools, right? And so this would be, the next stage, right, of what we could offer. And then fill it in. I mean, we talked about this ASHVIN toolkit throughout the presentation, right? Maybe also to start using some of our tools, developing from there. And this is something we can offer in the project. As I said, we requested resources for this from the European Union. We think it's very important. So the ASHVIN project should not be just in the ASHVIN bubble, right? It should be a project for whole Europe in the sense. And we are now at the stage to really looking for people that would be interested to work with us in this. I don't know if I forgot something, or if I explained it well.
Thank you, Timo. There is one question on the chat. Which softwares could be used for these smart buildings? Navis, Revit, other.
So maybe I try to answer this, but Rahul would be more the expert. So I think when you have Revit or Navisworks, these are traditional BIM-based software. So what you of course saw in our digital twin platform were parts, I call it the parts of a bigger BIM model, right? I think Rahul, you showed the retaining wall, the key wall, right, of
Yes.
Rotterdam. And that was probably, maybe, I don't know, modeled in Revit, right? And we have import possibilities to the IFC standard. So if you have a BIM model, a Revit model, ArchiCAD model, or only a 3D representation, right, created with Blender or any other tool, we can actually use this as a baseline for the platform for visualization, right? And then you have what Rahul called the things, and the representation of the things in a kind of 3D view that we can explicitly then couple to sensors. I hope that kind of makes sense. But we can work with that. We can help you to create these representations for the construction site. our feeling was always, and experience on the project was that like having a whole BIM model, big BIM model that comes from the design phase is actually, I would call it overkill. So we only extract a number of objects from these BIM models to create a very simplified representation that then allows project managers to really streamline, track the progress and the quality that was put in. I know, Rahul, if you want to add something.
No, you're completely right, Timo. The Navis and Revit, these are the proprietary tools that you develop your 3D models or CAD models or BIM models. You can use even the open source one from the Blender BIM or even the Open BIM. There are many open source solutions for this to design the IFC file. The main point is you have to generate the IFC file of your infrastructure, and then we import it into our ASHVIN tool for representation on the digital platform. And then before the import also, we connect the sensors as been shown from all the 3 different presentations today, that those sensors we have to connect it to specific BIM element for the proper representation and also for the proper analysis that what is happening at that specific element of the BIM or the infrastructure part of the building.
Thank you, Timo and Rahul. Would we have any other questions before we wrap up the session?
If I may
Please
ask a question about the fallback strategy. I mean, for example, in case of a sensor failure, what kind of fallback strategy is present in the system you developed?
So when the sensor has failure, so first of all, the sensor we receive the information from the sensor on a specific frequency, depending on how frequent we need that information. Okay, and if for the first case, if the sensor is faulty, it stops sending the message, or it might send a very bad message. Okay, it can be very high level or very low level kind of message that can be indicated in the system very easily that, okay, the sensor is either faulty or need to be calibrated. So that information will be provided on the dashboard. So dashboard today we have not presented. That was not the part of today's presentation. So the dashboard for the project manager can able to understand, okay, one specific sensor which is located into this part of the infrastructure is sending a faulty information or no information. This is the indication we can give. The rest, then the project manager or the IT person has to take care for the sensor.
Okay, thanks a lot for your answer.
brilliant. So if there is no other questions,
Maybe I want to add something to that answer.
Please.
Because we work with an industry-ready IoT platform here. We have functionality and tools in the platform, right? That, platform won't crash if the sensor doesn't send, right? Things like that. That used to happen back in the days when you didn't have such a platform, right? I mean, 20 years ago, when we wanted to connect to a sensor, it was very difficult, and you had to implement all these routines. What happens if the same sensor fails and so forth? And this comes, most of these things actually come with the MainFlux platform, right? That's why we think this IoT platform is actually the missing link to make this more practical.
Yeah.
For real application on the construction side, right?
Right.
It's really it allows really a seamless connection to sensors, and okay, then you have missing values in the sensor stream, right? Not your whole application will crash, or
Exactly.
what happened in the days.
Exactly. It will not crash the system. It will only allow the person to say, okay, this specific sensor is faulty or not sending data, whatever the reason is, there has to be detected. But still, other features of the platform will still work. Other sensors are still keep on sending the data to the system, and it can be saved. Even though if there is no internet faulty connection happen, so in the MainFlux platform, this gateway will select, which has been installed on the construction site, will collect all the data till the next time internet will be connected to the gateway, so that sensor will not lose the information ever for the system for the analysis purpose.
Right. Excellent. Thanks.
Brilliant. So do we want to wrap up here? Timo, Manuel, Rahul, Rolando, do you have any other concluding words you would like to say? Or
Yeah, I do.
yes,
Of course. So for everybody here is interested, right? So this was really also an open invitation. I don't know if you are construction site managers. I don't know your background, but you know, you might know somebody who might be interested. We are really serious. We would like to work with a large number of different construction projects across Europe. So this is really an open invitation. Please contact me or Mona or Rahul at this stage if you're interested, right? And we would be really, really thrilled to work with you, really, really thrilled to hear from you, to connect with you, and maybe, you know, create some sort of win-win situation where we can help your construction project or your friends' construction projects, right? And you provide us the opportunity to explore our platform further.
indeed. And in our ASHVIN social media website, you will find our contacts, and I will update some new information regarding this opportunity to onboard ASHVIN. So I will make sure that you all online today have an opportunity to reach out to us, and we can actually make something happen together. So with this, I would like to thank you everyone for connecting with us today. All the material will be uploaded in our communication channel, so you can go back into our session and the information recorded, and I will reach back to you also with some wrap-up words. So thank you so much for your time and involvement in the session, and let's stay tuned for further news from ASHVIN. Thank you so much. Bye-bye.